Okay, folks, we're going to redo problem number 1 with the classical approach. So, using your calculator or the formula like we did previously, we get a z-value of negative 2.53. Okay. So, the problem pretty much starts out the same. Notice it does not say p-value here. We're going to be using critical values. So, the null is the same. The null always gets an equal sign. Okay, p equals 0.50. The alternative looks just like the null. You just have to put either a greater than, a less than, or does not equal. Okay, so read the problem. Do we think it's less, more, or different? We think it's less. Okay, so less than symbol. Okay, now here's where it gets different. So we did this in the 2 previous problems. Let's just assume we can do that and get that negative 2.53 again. Okay, the alpha, the significance level, is 0.05 in this problem. It says a significance level of 5%. So alpha is 0.05. So I am going to draw a picture, a bell curve, and I'm going to put 0.05 on the, see how this is pointing to the left? On the left side. So let me shade over here and put 0.05. So now I need to figure out the critical value that corresponds to, that's a question mark, I don't know if you can see that well enough. What value corresponds to 0.05 on the left? We've looked for this number many times. Remember, you go hunting for 0.0500 on your Z table. So you see 0505 and 0495. We've done this one many times. So is it negative 1.64 or is it negative 1.65? Oh, it's an exact tie, so we average them out. So this value right here is negative 1.645. So that breaking point, that's our critical value, negative 1.645. That is our critical value. Okay, so what does that mean? This shaded region over here, the shaded region is also called the rejection region. Okay. So let's look at our test statistic. Test statistic is negative 2.53. Here's our bell curve. And we're trying to figure out where this negative 2.53 lands. Does it land in the shaded region or not the shaded region? Remember, 0 is in the center. So here's 0. And we have positive numbers to the right. The negative numbers keep getting negative bigger that way. So negative 2.53 seems to me to be about right there. So it looks like right there, right? Negative 2.53 is more negative than negative 1.645. So our test statistic lands in the shaded region. It lands in the rejection region. So if you land in the rejection region, that means you would reject the HO. Aha! Isn't that what we said before, the previous 2 times we did it? Yes. So we would reject HO. And if we reject HO, then we would get our same conclusion that we keep getting every time, which is just so if we reject HO, then we would say evidence suggests the coin comes up tails less than 50% of the time. Aha! So you see how we were able to get to our statistical conclusion. That was our goal. What's our statistical conclusion? We were able to get to that without a p-value, just seeing whether or not we land into the shaded region, the rejection region. So this approach is called the classical approach. So sometimes the book likes to ask you, oh, what are the critical values? And you're like, ugh, why don't I just use my calculator? But just make them happy. Do that. So we did problem 1 just now using the classical approach. Okay, so in theory, we're pretty good to go. Now we have a little worksheet with 4 problems. So buckle up. We're about to have more fun.